Okay, recap what we have been covered. So previously we convert a Gantt chart like that, a Gantt chart into AOA diagram like this one. And also we introduce you beside AOA, we also introduce you AON network. All right. So we have introduced you two diagram or two network, AOA network and AON network. And we have transformed the AON network with the bubble, with a simple bubble with a two hemisphere there into a matrix form, which is in this form. And we did a lot of calculation for that. All right. So we have changed this one with using the 6 matrix here. So as you can see here today, we still go back to this matrix. So just to recap, what is this matrix that you see on the screen later? So on the top left here is number activity. So here is 1 to 7. We're still taking the building house project as our example. So you will see number of activity on the top here. The number of duration here you extract from the Gantt chart or from the AON diagram. And then the rest you do calculation. All right. You do calculation. Here you do calculation. So these two we use the forward pass where we get these two number from the front, and then when we want to calculate these two number, we do from the back. Okay. So we have gone through all the definition for ES and EF and so on. Right. So last lecture we fill out all these matrix here, all this space here, with the help of everyone in the class. Okay. So last lecture we stopped at this diagram. Okay, I hope everyone back to your mind is back to this diagram. So yeah, so if you have this diagram, the notes that you have in front of you, it will be very helpful to follow along the content that we're going to cover today. Yeah. So this diagram, we will use this diagram, continue with our content for today's lecture. Yeah. All right. So let's move on using this diagram. Okay, using this diagram. So we have all these numbers. Okay, we have all these numbers. And now we talk about something new today, not new, but a new term for today, a new name for today. It's called slack. It's called slack. So earlier in the previous, I think, 2 sessions, we defined the critical path by calculating the maximum project time for the pathway, right? So we have 4 pathway on the diagram that we've seen from AON diagram. We have 4 pathway A, B, C, D that we calculated previously, and pathway of 1, 2, 4, 7 is the critical path. 1, 2, 4, 7. Okay, 1, 2, 4, 7 is a critical path. Okay, so this is what we calculate. So this is what we calculate earlier. We calculate the total times 3 plus 2 plus 3 plus 1 over here. We get 9. Again, look at your diagram. Okay, focus a little bit attention to your diagram that you calculate in the previous class. Focus on this matrix, this matrix, this matrix, and this matrix. And then you look at these 4 and then compare to this one, and this one. Do you observe something special about your critical path compared to these 3? Can you observe anything that is special about the pathway? Maybe I reverse back to this diagram a little bigger so they can see. So in previous earlier, when we do calculation, we have 4 pathway using this diagram. You still remember? We have A, B, C, D, and you calculate 4 paths. So we found out that 1, 2, 4, and the last one, 7, is a critical path. So pay attention to 1, 2, 3, 4. You can see as one set. Compare the data or the metrics of these 4 items here with these 3. Are you able to see something special between the critical path and non-critical path? Maybe I'll give you another 20 seconds just to observe. What can you observe from the screen here or from on your diagram that you developed last lecture? Can you observe the difference between the 2 set, first set here, second these 3 set here? What is the main difference, or what is the main similarity between the critical path member and non-critical path member? Sarini, are you in the meeting?
Yes, sir.
Okay, Sarini, have you observed the diagram? Have you
Yes.
observed? Okay, so what is your observation? What is the difference between the critical path and non-critical path? Well, what is your observation? What, you're running to your desk, is it? It seems very
No, 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 no. I'm just sitting and breathing.
okay.
Mm. So the critical part is taking a longer time, and the normal part is shorter duration.
Okay. Do you
The
observe the numbers? Can you observe the numbers that appeared in the critical path and the non-critical path? Inside the critical path, you'll see the patterns in the numbers. Do you see pattern in the numbers?
it uh it
Try
jumped
to
by 2. Is it
uh,
2, 3, 5?
you try to observe this member, this member, this member, and this member first. You ignore the 3 first. What do you observe? There's a pattern here. Do you see there's a pattern between these 4 members? Something that very same of these 4 members. Do you observe anything? Look at the numbers and look at the patterns.
The middle number is same,
Middle number. What about the,
and the last, the middle
yeah.
and last. No,
Do
no,
you
just
see this one and this one?
just the middle number same.
Okay. Do you see this one? Same, right? This one?
Okay,
Same
same.
or not? Look at this one.
Mm. Same,
This one. Then this one.
same, same.
Okay.
Yeah, same.
All right.
Mm.
Good. All right. Thanks, Salini. Okay. So anyone in the class still not able to see the similar number here? You still not able to see what is the critical path special things here? Do you see the second row? Same. The orange color and this color same. They also same. This block also same. 3, 3, 5, 5, 5, 5, 8, 8. This one 8, 8, and 9, 9. Do you see the pattern here? And then it compare to non-critical. You see this one? Not same, not same, not same, not same, not same, and not same. Here same lah. Okay. So this observation, it tell you once you develop the 6 metrics here for each member, you're able to identify uh, based on observation which is the critical member. Okay, so it works it works in all the AON diagram or network. So once you have this 6 matrix number over here for all the activity here, you observe the second and the third column. If the numbers is same, they are critical path member. Okay. So back to the previous one. Okay, so I highlight the member for you, just in case you didn't see the differences. I'm highlight the 4 member for you on the screen now. Okay, you should see that the one that I highlight on the screen here, they are critical path member. Okay, the top and bottom, they are the same. You follow the arrowhead, you will see they are the same number. Okay. What mean by critical member or critical path? It means that you cannot touch first activity, you cannot touch second activity, you cannot touch activity 4, you cannot touch the last activity. Meaning you should not allow any delay happen to this member, this member, this member, and this member. Okay, so in the exam or test, you will be asked to identify your critical path by highlighting the members. Okay, so in the exam, you will start with the Gantt chart, you will develop the AON or AOA diagram. After that, you will come to this diagram. When you come to this diagram, the question will extend further. It will ask you to use your pencil to maybe to use a dash circle to circle the critical member in your answer. So in this case, 1, 2, 4, 7, they are the critical member. So in the exam, you should use something according to instruction. Maybe you'll ask you to highlight, ask you to circle, use a dash circle to highlight the critical path members. Okay. Any questions so far? This is something today. Something new today. All right. Any question? Everyone good?
Yes, sir.
Yes, sir. Right. Stop me if you're not able to understand the diagram. Okay. It means that now you cannot touch 1, 2, 4, 7, and you can make adjustment to these 3. Okay. So this is just a notes. So these are the mathematics presentation on deciding the critical path, meaning ES equal to LS, EF equal to LF. So if it's not clear, you can see the diagram, this one, right? So this one equal to this one equal to this one. It will tell you that they are critical path members. Okay. So one new terms that we learned today is activity slack. All right. So if the two number is not same, if these two numbers is not same, this one and this one, this one and this one, they are not same, it means you have a slack time axis. Another word for slack time means there is an open window that you can play around and you can afford any delay activity on 3, 5, and 6. Meaning you can allow any delay in this 3 activity. However, you have to always calculate, you should always watch whether your adjustment, will it affect the final ending time here, for example. So how do you calculate the slack? You take LS minus EX. later start with the earlier start, or you just remember by box. You take the bottom one minus the top one. Bottom one minus the top one. Both give you the same slack number. Okay, so for example, what is the slack time for activity 3? You take 4 minus 3, you get 1 month. Either this one minus this one also get 1 month. What about activity number 5? Can you identify the slack time you have for activity 5? 6 minus 5, 1 month. 7 minus 6, also 1 month. So for activity 5, also 1 month. What about 6? Activity number 6, 7 minus 6, you get 1 month. 8 minus 7, you get 1 month. So 1 month here, 1 month here, 1 month here. The next question, you as a project manager, you should answer, is it really you have 3 months slack time you can play with? The answer is no. Okay, the answer is no. Okay, this is the important equation to find the slack time. Again, slack time, you take this one minus this one minus this one, yeah? Okay, LS minus ES, LF minus EF. You can build a table. So in exam, after you build this matrix, we expect you to build another table from here. What does the table look like? This table is the slack table, where you calculate the first column is activity name. Second one is your LS. This one is ES. Because you take this one minus this one, you get slacks. Or you take this column minus this column, you get the same number also. Any question? Any one of you don't understand how to get this table?
Doctor, the star indicates the critical path, right?
Which one?
In the activity.
Slack.
In
It means
the
this one.
activity column.
Oh,
The
this one.
star is the
Okay.
critical path.
Yeah, star means the, yeah, you've seen the star here. So, but this is just before that before it comes to, but initially we didn't know 1, 2, 4, 7 they are critical path. But this table, you can build from table also to see the critical path also, right? So as you can see from the table, right? If you take this one minus this one, if they are critical path, they are highlighted with arrow. If you have the red arrow or the same number, the slack number is what? 0. Because this one minus this one minus this one, you always get 0. Because they are the same number. So on the table, on the slack table here, if you see 0, it means they are critical path. This is another quantitative methods that we use to find which one is critical path. The one I highlight with the red arrow here is by observation. You observe the numbers, whether they are same or not. Second method is by table. By using slack table, you build slack table. Those with 0, 0, 0, 0, they are critical path. Okay. Then those with numbers, they are the time that you can play around, that you can afford delay. Activity that you can afford delay. You have anything that more than 0 means you have a slack activity here, slack activity here, slack activity here. Clear? Okay, it will take some time to transfer information from this diagram to this diagram, yeah? So usually here to here will take you about 10 minutes, including the calculation. Okay, so it will be good in the exam or test, you draw this one on one paper, half page, then you continue to build this table below this diagram or this network. so that you can extract the information very fast into the table here. Okay, so this is called activity slack table or slack table. Yeah. So sometimes the question will be very simple, guided you through. You will say, develop AON diagram with what, and then the question will continue. They give you a matrix, build your AON diagram with the matrix. I will give you a sample, something like that, but without number. I will give you like first one represent what, second represent what, and so on. Then you use the reference diagram to build this paper, this network. Once you build this network, there will be one section in the question. It will ask you, after you build the AON diagram or network, build a table to calculate slack. So this is a table that we expect from you. Okay, so this is a table that we expect from you. Okay, so from here, I highlight those activity with a yellow color arrow here. It means that this activity, they are non-critical and they can afford delay in the projects. Okay, so we check whether we can delay how long. So 3 activity here we can delay. This activity we can afford to delay 1 month. This activity also 1 month. This activity also 1 month. But is it the total we can delay 3 months? So let's check. So if you delay activity 3 1 month, right? If you delay activity 1 month, so this one we're going to drag to here. So this one, it allowed you to drag 1 month, right? It's like 1 empty room here, 1 empty room here, and 1 empty room here. Now you have a new guest coming in. So this one don't have a room already. So what you do? You move the room to another one. So this one, you still have 1 more room to play. So let's say you still have another new guest coming in. You still have another new guest coming in. So this room will fill up. Okay. So when these two activity was occupied or delay 1 month here, 1 month here, you can no longer delay your project here, because here 1 month, here 1 month, it become 2 months already. So this one cannot afford to accommodate 2 months delay. This one can only accommodate 1 month. So you can either delay this one or delay this one. If both delay 1 month, 1 month, your whole project going to slow down. Okay. So I put a highlight there. So activity 6 cannot be delayed if activity 3, activity 5 will delay 1 month. Okay, so although this one you have 1 month slack, but if this one delay, this one also delay, this one cannot afford already, because the time here will change. Time here will change. It will make activity number 6 cannot fulfill the time frame. The total time you need, it will be extended. So just be careful on this checking. Okay, so this is another area how you observe how good is your planning. Yeah. Okay, let's continue. So these 3 activity, 1 month, 1 month, 1 month, these 3 arrow here, we give it a name. They are called shared slack. Shared slack. So they are shared. Right? They share the same delay time. Meaning this one delay, this delay can transfer to this one can transfer to this one. Because you see the arrow was linked together. Okay, the arrow must be linked so that they can call shared slack. If the arrow do not link, they are not shared slack. They are just slack. Okay, so just look at the English name, then you know. Okay. Okay, the word shared is in front the slack here. Shared slack is because of the arrow. You have the precedence arrow here. This one go to here, this one go to here. That's why they call shared slack. Okay. So if you look at activity 3, 5, 6, the total time you can delay is 2 months and not 3 months. Okay. This whole set, you can the whole set now, this one, this one, this one, you can only afford maximum 2 months instead of 3 months. If this one do not delay, then this one can afford 1 month. This one can afford 1 month. Then it won't delay. If this one delay 1 month, this one, if this one delay 1 month, this one don't have delay, then this one still can continue 1 month here. Meaning maximum you can play around is 2 months for the shared slack here. Okay, so this one you need some time to really observe the numbers here. Okay. All right, so I just highlight, yeah. So what does this slack or the extra times that you can play around? It allows you as a project manager to diversify or to handle some delay in the critical path here. You can pull resources from for activity 3, 5 to handle project 1, 2, and 4, for example. Okay, you can pull resources that you need for these 3, upload into this 3 activity, so that you can afford some delay over these 3 activities. Because this 4 activity you cannot delay at all. So what happens if really something happened to this critical path? What you can do is you play around with the slack here. You pull your resources, because once you pull your resources, this one is going to delay. If you pull resources here, it's going to delay. So, but these 2 is you can afford to delay 1 month, 1 month. So when you pull resources, this one won't affect, this one won't affect, and this one won't affect also. Okay, you're going to balance your projects. Okay. So as a project manager, it is not good if you have the whole network you having the critical path. Mean whole network that you build all the same number, all the network inside your network. This one same, this one same, and this one same, this one same. All the metrics here is same. Then it is not a good project planning. Okay, it's not a good project management, because if every member is critical path, you're going to kill yourself, right? Your employee is going to work like hell, you know. So if one activity was down, or maybe in the projects, like for example, building house project, 1 employee or 2 employees have accidents, something broke, the pipe broke, then you are in trouble. Okay, then you're in trouble. When it comes to contract again, when it comes to contract, is any delay of the projects, it costs money. All right, it costs money to the company. So be careful when you plan. Don't put all the activity, critical path or critical activity together in one whole projects. Yeah, make some room for yourself. Okay. Same with your FYP, same with your FYP2 or any capstone design projects or any personal projects. Yeah? Same with this one. Have some room to play around in your projects. Okay, we have done with activity slack. We are done with building the metrics and so on. All right, we learned the second new thing today. We're going to look at probability, which means you need to pull what you learn in your mathematics under statistics chapter or probability chapter, where you're going to look at bell curve, you're going to look at histogram, you're going to look at variance, you're going to look at something called standard variation or variance, and then plotting the graph, sketching the graph. So you need to recall back what you learned in the mathematics 2 or advanced mathematics about probability. So this one is the application of what you learn in your mathematics model. Yeah. All right. So previously, when we talk about CPM and PRT, so previously, the one that we introduced to you is under CPM, critical path management. Now we introduce you probability analysis for PRT. So we have two. Today we already completed CPM. Now we look at PRT methods. So PRT methods, it use statistic method or probability approach to do calculation. Okay, this one you can read from here. Definition for probability. There's one word we will use is called beta distribution. Okay, it's called beta distribution. Okay, before that, do you guys need a short break? We have been more than 45 minutes in the lecture. I think we go for a short break.
Sir.
Okay, we go for a short break. Then after short break, we come back with this probability. Let me stop the recording.